of all, what is Nvidia RTX Spark? Well, it is a major breakthrough from Nvidia this year. This is a super chip which is trying to implement the SoC system on a chip concept for Windows PC for the very first time, which Apple did for Macs years ago. SoC is basically collecting all the hardware components of a PC like CPU, GPU and memory and putting all of them on one single silicon chip, which results an increase in battery efficiency, faster communication between various components of PC, that is lower latency, and also reduces the requirement of thermal cooling systems. So Nvidia is not just trying to promise a faster laptop, they are promising to create a new category of AI first PCs which will simultaneously act as a gaming machine, creative workflow and an local AI server. Now let us talk about some hardware specifications. First, CPU. Nvidia RTX Spark has Nvidia Grace, a custom 20-core processor which is co-developed with MediaTek based on ARM architecture, promising massive power with an incredible battery efficiency. Second, GPU. RTX Spark has an integrated GPU. Now don't make a mistake by considering it as a normal integrated GPU. It is a GPU which is based on Blackwell architecture, packing 6144 CUDA cores, having raw gaming and rendering power equivalent to a GeForce RTX 5070 graphics card. It also contains 5th generation tensor cores for AI acceleration, which results into AI performance up to 1 petaflop. Third, it has a unified memory of 128 GB. Friends, it is the real game changer. It is the secret weapon of this chip. You will notice why I am using such phrases for this chip. Look, if CPU or GPU want to talk to this memory, they can do this at a memory bandwidth of 300 GB per second. And if CPU and GPU want to talk to each other, they can do this at a combined memory bandwidth of 600 GB per second. Now you might be wondering, combined memory bandwidth of 600 GB per second, what does it actually mean? Look, if in 1 second, if CPU is sending an data of 300 GB to GPU, then in that same second, GPU can send 300 GB of data to the CPU through a connectivity link or a connectivity bridge called NVLink C2C. Now friends, in this hardware perspective, there is one minor bottleneck, but you don't have to worry about it. Look, the bottleneck is the upgradability is dead, because as the major components like CPU, GPU and the memory is tightly fixed on that silicon chip, now you can't upgrade the memory. Now look, I don't think anyone will need an upgrade in such a powerful laptop. Now let us talk about some user specific perks. First, local agentic AI. Most of the AI tools you use today like ChatGPT, Gemini, Claude, you have to send your data to a cloud server which sometimes can be slow or can raise privacy concerns. But with RTX Spark, Nvidia is trying to bring the data center level AI processing to your laptops. Traditionally, any PC would get choked up if you will try to run an AI model with parameters greater than 8 to 14 billions. But with the game changer, that 128 GB of unified memory, you can run 120 billion parameter model locally. They are also claiming a context of 1 million tokens, which means that you can drop entire textbooks, thousands of lines of codes, and your AI model can remember and reference this information at once without running out of the memory. Now Nvidia is using this power to fuel personal AI agents via a new runtime called Nvidia OpenShell integrated with Windows 11. So before you have to open apps and click around, but now you just have to give one prompt to that AI agent. Now that AI agent will securely coordinate through various apps and get your work done. For example, opening Photoshop, editing that image, exporting that image, drafting an email, sending it to a particular person, and etc. etc. Nvidia RTX Spark takes a good care of gamers. Historically, ARM-based chips cannot run heavy PC games, but Nvidia overcomes or bypasses this constraint by smashing a big GPU right close to CPU on that same silicon wafer. Nvidia promises a gaming experience of 1440p and 100 fps even with heavy ray tracing is turned on. But there is one problem. Look, some older games are specifically written for x86 architecture, so Windows have to translate this game into ARM architecture, and also the game's strong anti-cheat software may suffer from a performance dip until developers patch them. Now let us talk about some editing specifications. If you work in Blender or Unreal Engine, now you can render heavy 3D scenes in a portable laptop. They are also promising that the chip can natively decode and edit 12K 4:2:2 videos without lagging or requiring you to generate low resolution proxy files first. They are also promising that the chip can decode and edit 12K 4:2:2 videos without lagging or requiring you to generate low resolution proxy files first. App optimization. Heavyweight softwares for companies like Adobe are re-architecting their apps like Premiere Pro and Photoshop especially for Nvidia RTX Spark, promising up to double the speed for AI powered rendering, masking and export. Now let us talk about that ARM problem. You might have read a couple of comments on various YouTube channels claiming that the chip is powerful, but that decision that ARM based CPU is used in this chip is not a good one. But I will give you a couple of reasons why ARM based CPU was used. First of all, power efficiency. Look, x86 architecture uses 6 instruction set. CISC stands for complex instruction set computer, whereas ARM uses RISC instruction set, reduced instruction set computer. Now CISC is way more complex than RISC instruction set, but because of CISC, x86 is more powerful than ARM, but at the same time it consumes a lot of power. Now Nvidia wanted to add a desktop class GPU in a 14mm thin laptop. Now if they had choose a traditional power hungry x86 architecture, it would require massive cooling fans, big power brick, and the battery could die in just 45 minutes. That's why a power efficient ARM based CPU was a better choice. Now the second reason is clean slate architecture. Now x86 architecture has been laid down by legacy compatibility code. Still a new Intel chip can run a software from 1995, but ARM gave Nvidia and MediaTek the freedom to create a brand new SoC based chip. Hence, again, ARM was a better option. Now friends, the third reason is business and strategic reasons. Now look, Nvidia is already a leading tech company. dominating the GPU and AI market. Now, Nvidia is trying to enter the PC market, which is dominated by the Intel and AMD since years. And that XRTX architecture is been cross-licensed by Intel and AMD. Now just think a little bit, how will they ever dare to give license to Nvidia, which is trying to become a big rival to them? Hence, ARM, an open licensing model, was a better choice. Friends, one more reason. You can consider x86 as an engine of a massive truck. Now that engine can pull an incredibly heavy load, but at the same time it burns fuel like crazy. Whereas ARM is a high-tech tiny motorcycle motor. Now Nvidia wanted to build a sleek, slim sports car, and by using that electric motor they have saved a lot of space and battery power. So now they can introduce a massive rocket booster, that massive GPU, and right next to the ARM CPU. Hence, these were the reason why Nvidia chose ARM architecture.